Here. I'm currently working on a fun little electronics project. A couple weekends ago, I went to a model rocket launch up near Xenia, and I lost one of my rockets. I put a E12-6 into an Estes Hi-Flier XL, and I never saw it again. And I thought, oh, it would be terrible to lose another rocket. I need a way of being able to track them down. So, being an amateur radio operator, I do have a little radio knowledge. I figured I'd just build myself a little beacon, to transmit some a tone and my call sign out in Morse code, and I'd, in theory, be able to radio direction find the rocket. Let me show you my circuit. Here's my circuit. Originally, I was going to use an Atmel AT Tiny 85 chip, but there was an issue where the chips I had did not support the tone, which is kind of necessary to generate a tone and to do the Morse code. So I did a little research and I tried to upload a bootloader to the chips that would support it, but I was not successfully able to do that. So I decided, well, for now, I will just use some Arduino Nano boards, which I do not have. So for right now, for development and testing my code, I'm using this Arduino Mega. Also, another thing in testing, I was originally thinking about using a 3-volt battery. Those little round cell battery things, like a watch battery type thing. But the problem is 3 volts is just barely enough, and it didn't take very long for the batteries to get to like 2.8 or 9 volts, and the microprocessor with the load didn't like that, and it malfunctioned. So 5 volts is a better choice. I don't have any batteries that do 5 volts, so I figured I'd run it off a 9-volt battery. So doing that, I would need to step down 9 volts to 5 volts using a voltage regulator. So today I worked on the voltage regulator circuit, and that's what we have here. This is an LM317 and a bunch of resistors. Let me show you what those resistors are for. Looking at the data sheet for the LM317, you can see that there's 2 resistors, R1 and R2. R1, to get the 5 volts from 9 volts, R1 is a 220 ohm resistor, and R2 is 675 ohms. Looking back down at the circuit, you can see that I have a 220 ohm resistor going between pins 1 and 2, and also I have going from pin 1 to ground, I have also between 1 and 2, I have 2 330 ohm resistors in series because I do not have a 675 ohm resistor, and 2 330 ohm resistors equals 660 ohms, just close enough to 675. Okay, and that does produce a nice 5 volts from the 9 volts. And then the rest of the circuit is a blinking LED to show the Morse code and a 433 megahertz RF module. Using my desktop power supply, which I got for Christmas, thank you, Santa Claus, I have outputting 9 volts. And as you can see, the circuit is now running. It's blinking away, now it's doing a tone. And if I turn the radio on, and the radio is a little noisy because of the RF interference from the computer and everything running. Could be the monitor also. You can see the 5 volts. So 9 to 5 volts. So, anyways, that's my circuit. I'm going to be designing a schematic, a circuit board, so I can actually have something to solder on. When I get the nanos, I'm just going to use some boards that I can solder down and just use wire. But I do plan to make a couple of circuit boards using one of those Chinese circuit board manufacturing companies, and have some much better boards to put in rockets, because I'm not sure how well my hand soldered devices will last in a rocket. So, hand wired, I meant. So yeah, this is a fun project. I learned quite a bit. I destroyed 2 of my radio modules, unfortunately. They seem to be rather fragile. And I did order some antennas, because you do need to have an antenna for these. This has been fun, experimenting and learning, and it's definitely a worthwhile project. Even if the outcome is not as successful as I think it is, I still gain in the knowledge I learned. It's a win-win situation. Sin 3 VQW 73.